Hello, hello, what's up everybody? Check, check, microphone checker. Hope you all are doing well. John the Morgile here, checking in for a Flat Earth live stream for you guys. Hope you enjoy it. And today we're going to be talking about fake space and NASA lies, per the usual. Alright, I think we're live. Let me just get a confirmation before we take
Hello,
off.
hello,
There
what's up
go.
everybody?
Looks good here. Alright, so today we're going to talk about Voyager 2. And I actually mentioned Voyager 1 in a video years ago, and so Voyager 2 is now in the news as of late, and we'll get into the reasons why, but this is pretty much hot off of the NASA bullshit presses, the Voyager 2 story, where this thing that was launched in the 1970s with hardly any power to speak of, hardly any transmission capabilities to speak of, is, I forget the distance, but we'll get into that as well, but just a ridiculous distance away for decades and decades and decades, running on 70s technology, still transmitting data from the edge of space through the asteroid belt, mind you, allegedly, just hundreds and hundreds of millions of miles away. And wait till you see what they say Voyager 2 has discovered here just a few days ago, now that it has finally escaped the so-called solar system. So, just more NASA lies, and they got to keep something in the news all the time to try to stay relevant, keeping people's minds like a worm in the brain, right? Keeping the worm in your ear. It's NASA for you. So here we go. We're going to start off with a little clip. It's about 15 minutes, but I'm not going to play the whole thing. But this just sort of gives you the standard viewpoint and story on this whole Voyager 2 thing. And don't you love the CGI? He literally starts this thing out and he says, "This here is Voyager 2," and I would just make the little caveat statement that it is, of course, a CGI composite, not even supposedly the real thing. And of course, you will never see pictures of satellites in space. You will only ever see CGI composites like this. So anyway, let's kick it off with this video called Voyager 2 discovers wall of fire at the solar system's edge. And this channel here that we're watching is called Anton Petrov. I'll try to remember to put a link in the description. And let me play this for a minute and see if you guys are getting buffering issues before we continue. So we'll kick it off and I'll jump back to the chat in just a minute.
Hello wonderful person, this is Anton, and this right here is one of the Voyager probes. I don't know which one, maybe two, they look exactly the same. Now I wanted to start this video by...
Like, did you catch that? He said, "This is the Voyager probe." And he said, "It may be one, it may be two. It doesn't really matter because they both look the same. But I would point out that it is a cartoon picture drawing. It is not either." Ah, goodness gracious. And clearly, it doesn't even appear to, it's not even as if they tried to make it appear as if it were actually the Voyager probe. It is clearly a CGI composite rendering, whatever. Computer graphics.
possibly finding something around the house, or possibly something my parents may have had that worked for a long time. The only thing I have that's relatively...
I'm not sure what just happened there.
I guess you can call it old, is...
The audio just crapped out. Maybe it's my headphones. Did the audio crap out for you guys too? Hold on. Let me know in the chat if the audio crapped out for you guys just there on the video. Let me try it again. Of course, every time I switch between windows, it wants to lag me down.
This right here, this is actually a Geiger counter
terrible.
that you can use to detect various types of radiation, and I've used this in one of the relatively, I guess you can call it old, is this right here.
What in the crap?
would otherwise strike our planet and our solar system. You can see in this graph how as soon as...
Let me try just some random video. Sorry, y'all. This is kind of silly. I just tested it. Wow, this one seems to be working. So it's specific to that video? That's really weird. How does that work? How can the audio be messed up?
Would otherwise strike our planet and our solar system. You can see in this...
me at all. And I just watched basically the whole thing earlier, and it was not like that. And in fact, when I started the video, I believe it was also sounding just fine for a minute. So not exactly sure, but I suppose we can go ahead and skip this because there's obviously no sense in watching the whole thing if you can't hear it, so forgive me, but we're going to cover pretty much all the points that he goes over in this little video anyway. And again, I'll try to remember to put a link in the description for you guys, so in case you want to watch something that's going to make you want to rip your hair out and scream at your computer monitor, that's up to you. So let's get into the wiki then. So Voyager 2, they say, is a space probe launched by our favorite people in the world, NASA, on August 20th. Oh, I never did look to the chat to see if you guys had audio issues on your end or if it's just me. So, shit, let me go back up. The audio was good. John Jeweler says it's working. Gone, dropped, back on, gone. Strange. Okay, so let me just let it play, and I'll let it play for a good while, and the next time that I pause it, I'll try to remember to check the chat to make sure that you guys can hear it, but just so you know, I can't really hear what he's saying, so I won't be able to comment much on it. Where are we at, like a minute? I don't know. Not even? It was like right here still, wasn't it? Okay.
I've used this in one of the previous videos where I tried to calculate how much radiation I was exposed to up there in the skies while flying in an airplane. And this thing is actually not even that old. It was actually bought in the late 90s, possibly 1999 or maybe 1998.
It's not that old. He said it was bought in the 90s.
So technically it's about 20 years old, and it still works pretty well. It uses a few AA batteries, and by the way, this is totally not a sponsored video. It's just the only thing I could find that just still works after 20 years. Which is why this next segue should totally blow your mind. This beautiful piece of hardware has worked for 42 years in space.
Okay, so let me just check back and see. Could his voice wasn't totally garbled to you guys there? Give me a thumbs up if it was good audio. Playing good. Okay, well I just can't hear it, so I'll just let it play a minute, although I don't know exactly what he's saying. So.
In these super inhospitable conditions, filled with radiation, extreme cold, and always bombarded by all sorts of miniature particles. So both Voyager 1 and Voyager 2 has been out there for 42 years and they still work. What's even more mind-blowing is that the scientists currently getting all of the data and studying all of the data, a lot of them, actually possibly most of them, were not even born yet when the probes were launched in around 1977. Now this video is obviously not really about how ancient these probes are. This video is about the fact that both Voyager 1 and Voyager 2 probes are technically now in the so-called interstellar space. Because NASA has just recently confirmed that Voyager 2, that was sort of lagging a little bit behind Voyager 1 because Voyager 1 is moving faster, has now officially reached what we would refer to as interstellar space, as indicated by its still functioning devices that we have that suggest to us that there is definitely an actual barrier between the so-called solar system and the interstellar space. And in this video I wanted to discuss some of these findings and to give you a kind of understanding of what's out there in the interstellar space compared to what's here in the solar system. But before we start, I'm sure a lot of you will probably ask what this long thing is here and why is it even there. Well, this is actually just a beam-like structure to separate the magnetic field detectors, the low field magnetometers as they're known. There's one right here and there's another one on the tip. And the reason they're in that location is to isolate them from the magnetic interference that might come from the craft itself. So that's really the only reason for this long structure. Also, this thing that's sticking out, that's the so-called RTG, or in more common terms, the nuclear reactor that's powering the probe, and we think that it's probably going to finally die somewhere around 2025. We're not entirely sure, but the probe probably still has about 6 to maybe 8 years left in it. Then right here you can see something shining. This right here in the middle, that's the super famous golden disk, also known as the golden record. It contains this information here, which basically presents a few hints about who we are as a species, and the location of the solar system right here is designated using the data from very well-known pulsars. This is in case anyone wants to actually find us. Maybe not a good idea, but now there's no way for us to ever get this disk back. It also has, as you can see, the sounds of Earth recorded on the disk. And in a sense, this is probably the most expensive record that we've ever created, and if we were to ever recover it, it would probably cost a lot of money. But anyway, then we obviously have a lot more sensors here, and a lot of them still function, and this is how we were able to get all of this data about the so-called interstellar space. So what exactly have we actually confirmed this time? Well, so first of all, we've predicted that there was something known as heliopause. This is the kind of a boundary between the end of the solar system and the beginning of the interstellar space. And as you can see, it's sort of formed by the essentially sun itself. More specifically, it's formed by the magnetic field of our sun, while at the same time, it's formed by the interaction with the interstellar magnetic field, which is actually formed by various really highly energetic events, such as, for example, supernova that happen here, that do create magnetic field in the interstellar space. And what's interesting is that one of the main discoveries here was that both the solar magnetic field and the interstellar magnetic field are actually aligned with each other, which is something we didn't really expect to find. In other words, the magnetic north and south pole for both the solar system and the interstellar space seem to be aligned. And interestingly, in this graph that was presented in one of the papers that you can find in the description below, you can also clearly see that the strength of the magnetic field increased when the craft left the solar system space and entered the so-called interstellar space.
That's pretty much everything that I wanted to hit on this video. He goes on, and I could probably skip ahead to some other points, but we're going to cover a lot of this stuff thoroughly. So, first of all, I think it's really... Well, let me stop talking while I'm doing this because I don't want to have to repeat myself because the stream craps down. So anyway, this whole idea of the heliopause, I don't know, is that clickbait because they call it a wall of fire? I think he goes on later somewhere like way down the line to explain what they mean by wall of fire, but basically it's magnetic fields and plasma type situation that they claim that these little Voyager craft went through. And supposedly Voyager 2 is the one that sent back this confirmation of this, essentially what they are claiming is a wall of fire. But just if you look at the story of Voyager 2 and Voyager 1 to begin with, especially knowing what we know now, and that being that space is fake, then the story really falls apart. Like everything about it falls apart. So let's now go to the wiki, like we were going to do. So they say Voyager 2 is a space probe launched by NASA on August 20th, 1977 to study the outer planets. The part of the Voyager program, it was launched 16 days before its twin Voyager 1. That makes sense. Launch Voyager 2 before you launch Voyager 1. Makes perfect sense. On a trajectory that took longer to reach Jupiter and Saturn, but enabled further encounters with Uranus and Neptune. It's the only spacecraft to have visited either of these two alleged ice giant planets. Voyager 2 is the fourth of 5 Limobiles to achieve the solar escape velocity, they say, which will allow it to leave the solar system. So they say its primary mission ended with the exploration of the Neptunian system, October 2nd, 1989. After having visited the Uranian system in 1986 and the Saturnian system in 1981, a good year, yes, and the Jovian system in 1979. Voyager 2 is now in its extended mission, well, no shit, to study the outer reaches of the solar system, and has been operating for 42 years, 2 months, and 25 days as of November 14th, 2019. It remains in contact through the NASA Deep Space Network. Like, let's think about this for a second. Imagine if you have like an original Atari console, right? And you put it in a super vacuum in super cold conditions at super velocities, and then just expect that technology to work like a charm without any sort of failure or crap downs for 40 something years. Like, if that's about how ridiculous this is, because the technology from the 70s, uh, it's just, I'm sorry. But first of all, and we'll get into it again, but the distances they're claiming that this thing is, with the amount of power that it has, with the amount of radio strength, radio frequency strength that it has, its transceiver strength, it's absolutely absurd for them to claim that they're still communicating with this thing through such vast distances in this old technology with no maintenance in conditions that are probably the harshest imaginable conditions. And yet they're claiming that it's going to keep on trucking for another several years at least. They'd be surprised if it didn't. And my God, if people like this guy that actually believe this because they see CGI pictures and they get data back from NASA, it's pretty sad, man, because we already know that NASA is completely full of it. They've been lying since they started. Their whole inception was shrouded in deception, lies, and propaganda. And so, anyways, we'll continue and we'll get into some of the specifics, but we'll just continue with this introduction on Wiki. It says its primary mission ended. Oh, wait, the extended mission. Oh, and then it goes into the NASA Deep Space Network, which I looked into that a bit. It's nothing super interesting that I could find right on the surface, but I'm sure if you dug into this NASA Deep Space Network for more than the 5 minutes that I did, you can find some sort of corruption or deception, as NASA and every dark annal of its past is rife with that sort of thing. So they say that at a distance of 122 AU, and that means astronomical units. So one astronomical unit is the distance from the Earth to the Sun in the Ball Earth theory model. So 122 of those, that's hundreds, how many millions? 16.58 light hours, or 16 hours, 58 light minutes from the Sun. So it's 1.83 times 10 to the 10th kilometers. Just give it to me in miles. They won't do it. But what is that? Over a billion miles? Okay, wait. 122 times what was it? 93 million, right? 1 AU is 93 million, right? So let's just do it. I don't know where my calculator is on my phone. Hold on. I'm not going to try to do that in my head. So 122 AU times 93 million miles, right? Oh, well, that's 1.1346 e to the 10th, so I don't even know. It won't even give it to me on my calculator here. So, it's a lot of damn miles. And, have you ever used like a walkie-talkie, guys, or a CB radio, a little RF transmitter, a transceiver radio, whatever, transistor? Um, like, for them to claim that that thing is communicating on 70s technology with no maintenance in the vacuum of alleged hypothetical non-existing space since the 70s? I mean, that is, frankly, that's absurd. They should have folded on this. I'm sorry, but NASA should have folded on this a long time ago, because the longer they keep these tin cans going, the more and more ridiculous they seem to the casual observer with any sort of skeptical criticism in their head when they're looking at this sort of thing. But we'll continue. So yeah, at a distance of 122 astronomical units, so that's 1.3 times 10 to the 10th kilometers, about 16 light hours from the Sun as of November 5th, 2018, moving at a velocity of 15 kilometers per second relative to the Sun, of course. So I wonder if these Voyager probes are going in the same direction as the sun, or in the opposite direction as the sun. Because wouldn't that matter a bit? Because of course, if you're going in the opposite direction that the sun's traveling, then you get a bit of a bonus. That 483,000 mile per hour velocity of the sun, wouldn't you? If you're going in the opposite direction of it. But if you're going in the same direction as the sun, then a mere, what did they say? How many kilometers per second? 15 kilometers per second? Well, then I guess the sun would catch up with them eventually if they were going in the sort of the same direction now, wouldn't it? Or maybe they're going at some perpendicular direction to the sun's velocity, but that would make a big difference in their relative speeds now, wouldn't it? But of course, they don't ever give you that sort of information. They just assume that people won't ask those sorts of questions because, we're led to believe that in space there is no sort of relative speed between objects in conflicting motions, right? Because that's what must be true in space in order for the ball Earth theory to work in so many ways, like orbital mechanics and just stuff we're not going to get into. But it is a good question to keep in mind, right? These little generic ass tin cans from the 70s going 15 kilometers a second. Right. So it says that Voyager 2 left the heliosphere and entered the interstellar medium, a region of outer space beyond the influence of the solar system, joining Voyager 1, which had reached the interstellar medium in 2012. Voyager 2 has begun to provide the first direct measurements of the density and temperature of the interstellar plasma. So not only is this thing sending back telemetry data, they claim, but it's sending back literal like analyzing samples on board, which, by the way, all of these components have been in the harsh environment of alleged hypothetical non-existing space for decades with no maintenance, and they're just chirping along just fine, just running like a charm, because you know how that's exactly how 1970s technology operates to this day, in all cases, with no maintenance. Of course. Of course. So let's get down to the communications section here. It says built with the intent of eventual interstellar travel. Voyager 2 included a large 3.7 meter or a 12-foot parabolic high gain antenna. Yeah, it better be high gain, buddy, to go 120 astronomical units. 93 million miles times 120, whatever the hell that is, which I'm not even going to try to do in my head, and I'm not, I don't have a pen handy, so I'm sorry. To transceive data via the deep space network on the Earth. The communications are conducted over the S-band, about 13 centimeter wavelength, and X-band, about 3.6 centimeter wavelength, providing data rates as high as 115.2 kilobytes per second. What? On 1970s technology, they had 115 kilobyte per second Wi-Fi? Really? Come on now. This is just absurd. 115 kilobyte per second. I remember having dial-up where if you had 99 kilobytes a second, you were hauling ass, and that was in the late 90s. So, like, what the crap? Why couldn't they have done that? Why could whatever? Wirelessly, really, over millions of miles. Sure you are, NASA. We believe you because we all just fell off some turnip truck yesterday, buddy. I'll tell you that right now. 115 kilobytes per second at the distance of Jupiter, and then ever decreasing as the distance increased because of the inverse square law. Well, no shit. So, what does the inverse square law say about 120 astronomical units radio frequency transmission? Like really, I love how they bring this up, and then they'll give you a link to the inverse square law, which that's been discussed plenty, and I don't think I'm going to get into the weeds on the inverse square law because we all pretty much know what that is. I'm not gonna get too into that. It's sort of not germane to this exact topic, but they say when the spacecraft is unable to communicate with the Earth, the digital tape recorder can record about 64 megabytes of data, 64 whole megabytes of data, for transmission at another time. So it's got a little, like, I don't know what, hard disk or memory chip on there with 64 megs of data, 115 kilobytes per second. You can fill up 64 megs in what, I don't know, an hour, something like that, couple hours. But so it does sort of a backup and then transmits that data at another time, as they say, 120 astronomical units. through the asteroid belt and hits their little radar in Houston, Texas, perfectly on 1970s technology with no maintenance. Yeah, it is. It's total bullshit. So here's another one. Voyager 2, the power. Voyager 2 is equipped with 3 multi-hundred-watt radio telescope thermoelectric generators, which that sounds very, very fancy schmancy indeed. But I'll tell you what, it says here, each RTG, they call them, includes 24 pressed plutonium oxide spheres, which we will get into these in just a minute. But it says 24 of these plutonium oxide spheres and provided enough heat to generate approximately 157 watts of electrical power at its launch. Collectively, the RTG supplied the spacecraft with 470 watts at launch, and that 470 watts will decrease by half every 87.7 years, they say. As if NASA has been studying these sorts of generators for, for 90 years, of course. Like, how do they know that without first observing it happen and then observing it happen again in another 90 years? I mean, the claims that they make on their technology is just absurd. But so before we go any further, let's look at these plutonium oxide spheres, because they didn't leave a link for it, but I just sort of took on my own volition to look at that a bit. And what I found from a cursory little bit of research is that these sorts of generators were designed by NASA specifically for these probes, and you really can't find any other sort of practical applications for a generator that will work in a vacuum of space for decades with no maintenance. There are no other, and maybe I'm wrong here, but I couldn't find any other sort of practical applications for these sorts of plutonium oxide sphere generators, which you would think would be sort of invaluable, wouldn't it, in a lot of ways? So that right there to me is just a bit questionable, but they do have very rigid laws on plutonium oxide, so not just anyone can get their hands on it, and I guess they don't want them just anywhere. But it makes you wonder, like the things like let's just say the nuclear power generated subs. It just makes you wonder, are they just actually harvesting energy from the ether and not using this sort of a technology at all? And they have all the rigid laws against the so-called radioactive isotopes to keep it out of people's hands to protect them from getting caught in their lies. Now, that's just a question. I'm not throwing out any wild accusations, but you would think that this sort of a technology would be more prevalent to not just everyday average Joes, but to industries. I don't know, some sort of practical applications. But no, really, as far as I can tell, these plutonium oxide sphere generators that work for decades and decades and decades with no maintenance are really only used by NASA, which to me, that's just raising up all sorts of red flags, and it definitely deserves being delved into a little bit deeper. So that's exactly what I did. Um, here's the wiki on these plutonium oxide spheres, or plutonium oxide in general. Um, Chemical compound with the formula, da 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 da. So you go down to the applications, and it says really the here, and you'll see this in several different instances, but it says that this oxide is used for MOX fuels for nuclear reactors. Plutonium-238 dioxide is used as fuel for several deep space spacecraft, such as the New Horizons Pluto probe, as well as the Curiosity rover on Mars. So, okay, so there's an exception. It's not just for the Voyager crafts, it's also for the Curiosity rover on Mars, which you can go watch it rove around on Mars in a CGI composite animation for about an hour on the Discovery Channel or whatever. Maybe it was Nat Geo. So they say the isotope decays by emitting A particles, which then generate heat. But so the applications, you like scan through it. I've scanned through several different articles and sources, and you really can't find any practical applications for it other than NASA and nuclear generators, allegedly. So let me close that. Radio telescope thermoelectric generator. So here's this specific type of thermoelectric generator that is made by those spheres. It says a radioisotope thermoelectric generator is an electric generator that uses an array of thermocouples to convert the heat released by the decay of a suitable radioactive material into electricity by the Seebeck effect. This generator has no moving parts. Well, that ought to make it pretty convenient, huh? RTGs have been used as power sources in satellites, space probes, and uncrewed remote facilities such as a series of lighthouses built by the former Soviet Union inside the Arctic Circle. So pretty much in the realm of where nobody's going to go and verify it. But okay, so there's one other not so practical application because I mean, how many, lighthouses do you need in the Arctic Circle? Right, but I guess the Soviets, there you go. So there's another top secret military, unverifiable, unfalsifiable, claimed application of this sort of a generator. So the RTGs are usually the most desirable power source for unmaintained situations that need a few hundred watts or less of power for durations too long for fuel cells, batteries, or generators to provide economically, and in places where solar cells are not practical. Safe use of RTGs requires containment of the radioisotopes long after productive life of the unit. So wait a minute, let me read that again. Safe use of the RTGs requires containment of the isotopes long after the productive life of the unit. Okay. The expense of RTGs tends to limit their use to niche applications in extreme situations. So, there's a little bit about that. These claims are just so ridiculous. Now, I got into the weight of each one of these. Each RTG had a total weight of 37 kilos. 24 pressed plutonium-238 oxide spheres, provides enough heat to generate approximately 157 watts of electrical power initially, having every 87.7 years. And then they say each RTG generated about 2,400 watts of thermal power. Conversion of the decay heat of the plutonium to electric power used 312 silicon-germanium thermoelectric couples. The initial thermoelectric couple hot junction temperature was 1273 degrees Kelvin, or about 1800 degrees Fahrenheit, with a cold junction temperature of 573 Kelvin, or 572 Fahrenheit. So it says here that it provides enough heat to generate approximately 157 watts of electrical power. 157 watts. So to put that into perspective, here's a little basic toaster oven example of power usage. It says a toaster oven is usually 1200 watts, but remember that's the hourly rate of electricity consumption, so it consumes 1200 watts an hour after 1 hour, or 1200 watt hours after 1 hour. Due to the fact that it is operated only for a few minutes at a time, however, the consumption per use is not as much as you would expect. Okay, but if you were to run a toaster oven for an hour, it would be 1200 watts. Now, again, the Voyager 2, they claim, had an initial power which is going to decrease by half every, 80 or whatever years. 157 watts. So convert watts to volts, and we'll just say it's what, I don't know what the amp should be. Well, whatever. So don't care. And I actually looked for the amps. It doesn't actually tell you in here, I don't think. So anyway, what they're saying here is that the thing run at its maximum capacity, I believe, unless I've got this wrong, but it could generate approximately 157 watts of electrical power initially, and that decreases by half every 90 years, basically, they say. So really, 120 astronomical units on 157 watts of electrical power. Now, also, I thought was kind of interesting this hot and cold junction temperature. So if you just look up the hot junction temperature on just a web search, it says it's the measuring point on a temperature sensor, most commonly a thermocouple, right? So that's exactly what they said it was for, or what it was on, or whatever. It says it's the point where the positive and negative legs of the thermocouple wire are welded together. So, I am curious to know what sorts of materials they're actually using, um, that sustain what was it, almost 2,000 degrees Fahrenheit? I believe that's what it was, like 1,800 degrees Fahrenheit. I said at these hot junction sensors. So I don't know. I mean, I'm not an electrician that deals with this sort of thing, but that seems pretty damn hot to me. Maybe that's standard, but it seems very hot because a lot of elements melt at well below that. There's only a handful of elements that have a melting point that's higher than 1,800 degrees Fahrenheit. Just saying. So let's close that. But just absolute reeking of NASA lies and bull. It says each RTG, again, this is still these generators made by the radioactive spheres, they claim, generated about 2,400 watts of thermal power. Conversion of the decay heat of the plutonium to electric power used 312 silicon. Oh, I already read this, didn't I? Okay, sorry. Each Voyager spacecraft has 3 RTGs. Okay, so collectively the 3 combined, they had 470 watts total at launch. Okay, so I was slightly off by the 157 watts. You had to multiply that by 3 or whatever. So 470 watts of power at launch, and again, that's going to decrease by half every 90 years. So by now, it must have decreased by about a quarter. So according to even them, they're down to less than 400 watts. And yet they're still able to allegedly telegraph their data at 100 and something kilobytes per second on 1970s technology. I mean, man, they really had it going on in the 70s with their technology, let me tell you. It says the MHW RTGs were used on the Lincoln experimental satellites 8 and 9, so more NASA applications that nobody will ever verify in a million years, even if it was possible, because you'd never catch up to them, right? They've got a 120 astronomical unit head start, so even if you believe that you have the technology to go and double check what NASA's telling you, it will never catch up to their probes that are definitely not out there 120 astronomical units away. I promise. I would bet my hat on it. Subsequent U.S. spacecraft used the GPHS RTG, and I believe somebody got paid $250,000 to come up with that abbreviation. Which use similar SIG thermoelectric devices, but a different packaging of the fuel. Really. So there's a little bit about that. So, like, really, if you believe that they are, oh, and I'm not even sure we looked at the radio frequency stuff yet, but it's just as ridiculous as the power. I don't even think you need to get into the radio frequency strength, and I think maybe we touched on it, but I don't even think you need to get into that once you've looked at what they're saying is powering this thing, generating radio frequency signals that are somehow able to propagate through the vacuum of space. 93 million miles times 120 or whatever. Really? That's absolutely absurd. It says, okay, here we go. Voyager 2 is now slightly more than 11 billion miles away, or 18 billion kilometers. Really? So yeah, you can send radio frequency signals through space on a basically. Is that am I tripping here, or that's hardly enough power to run a toaster oven for a couple minutes, right? I mean, yeah, and they're sending radio frequency signals 11 billion miles. Okay, sure, 11 billion miles, my ass. Okay, so here's a JPL article about Voyager 2 illuminating, and I wonder if this is a keyword here, the boundary of interstellar space. So, oh, this is an old article too. So this is November 20. Okay, no, it's not. This is just from 12 days ago, November 4th, 2019. So they're referencing something that happened last year, allegedly. It says 1 year ago, on November 5th, 2018, NASA's Voyager 2 became only the second spacecraft in history to leave the heliosphere, the protective bubble of particles and magnetic fields created by our sun. Really? So you're telling me there's a bubble of particles in space? Ugh. Whatever. At a distance of about 11 billion miles from Earth, well beyond the orbit of Pluto, Voyager 2 had entered interstellar space, or the region between stars. Yeah. Today, 5 new research papers in the journal Nature Astronomy describe what scientists observed during and since Voyager 2's historic crossing. Each paper details the findings from one of Voyager 2's 5 operating science instruments. So here's what they're saying it has on board: a magnetic field sensor, 2 instruments to detect energetic particles in different energy ranges, and 2 instruments for studying plasma, a gas composed of charged particles. So, let me just put this in perspective yet again. Have you ever used an office printer pretty rigorously, pretty heavily for years? Like, could you imagine trying to run that thing for years with no maintenance? Like, don't bother changing out the toner. Don't bother, cleaning out the heads ever. Don't, no maintenance. And by the way, put it in a deep freezer that happens to evacuate its atmosphere to well below anything that we can get on Earth. Allegedly, you're talking about basically a perfect vacuum. And see how that printer does for 40 years with no maintenance. I mean, this is magnetic field sensors. I mean, could you imagine trying to use your first pager that you got in the early 90s? You remember beepers? Like, could you imagine if you were still using that thing and you expected it to continue working for another 20 years with no sort of maintenance? You don't even need to change the battery, right? What the? Uh, so, so just continue on with this ridiculous article. Voyager 2 had entered interstellar space, they say, or the region between stars. Today, 5 new research papers in the journal Nature Astronomy describe what scientists observed. Right. Each paper details the findings from one of Voyager 2's 5. Oh, wait, dude, I am totally reading this crap again. I need to scroll down. Shit. Okay. The sun's heliosphere is like a ship sailing through interstellar space. Both the heliosphere and interstellar space are filled with plasma, a gas that has some of its atoms stripped of their electrons. The plasma inside the heliosphere is hot and sparse, while the plasma in interstellar space is colder and denser. So basically, what they're saying is they hit essentially a brick wall of hot plasma way out there, 120 astronomical units from the Earth. And it didn't damage any of their sensors, But again, plasma's going to do some damage to electrical components, will it not? I mean, it certainly will to anything living. We know that, but we're talking about plasma here. That's electrically charged gases which somehow cling together out in the vacuum of space, which doesn't make any sense. Much like the nebula that we discussed the other week, you can't have conglomerations of diffuse gases in a vacuum, because diffuse gases will always expand to fill their container, and of course their container is supposed to be the infinite vacuum of space, which means they would keep expanding to infinity. You wouldn't have any sort of conglomeration of gases, but they're saying that you have this conglomeration of gases and plasma, no less, which means it's negatively charged ions in the gases, right? That's what plasma is. So, and that's hot and sparse. Okay. So, and again, I always question, well, how can something be hot and sparse? Because really the definition of heat, as far as I know, is that, and I don't necessarily agree with it, but this is their definition for heat, is the atoms in a given substance are excited and bouncing off of each other very rigorously. Okay, but if you have those atoms spread out to where they can't bounce off of each other, then you don't get that heat. So really, the definition of heat, if unless I've got this way wrong from physics classes a long time ago, but the very definition of heat, you have to have a close condensation of the particles that make up that substance. So there is a bit of an oxymoron here, or a bit of a discrepancy in what they're saying in terms of things like the ionosphere, even, or definitely this heliopause, where they're claiming that it is high heat, or the thermosphere here on globe Earth land, the thermosphere, they say, is very, very hot, but the reason that it doesn't damage anything is because the particles are very, very far apart from one another, so it's a very low density situation. So they're claiming that you have very hot particles that are not close together, and I just don't see how you can get heat from that, because heat is basically an average of temperature of particles. So if you've only got one particle per 100,000 cubic meters or whatever, then by definition it cannot be hot. I don't get it. There's a discrepancy here in what standard physics tells us heat actually is, and these particles that somehow manifest in conglomerations out in the vast reaches of infinite space, the vacuum of space, no less. Well, that's different. But they say the plasma inside the heliosphere is hot and sparse, while the plasma in interstellar space is colder and denser. The space between stars also contains cosmic rays, or particles accelerated by exploding stars. Voyager 1 discovered that the heliosphere protects Earth and the other planets from more than 70% of that radiation. Oh my goodness. So just more garbage, more. I think there was some things I wanted to hit on in here, but we probably already covered them. But let's just see. Pushing through the plasma, the two Voyager spacecraft have now confirmed that the plasma in local interstellar space is significantly denser than the plasma inside the heliosphere, as scientists expected. Of course, because scientists are always right when it comes to space, because it's just much more fun to pat yourself on the back for being right than to having to admit that you were wrong about something. So you might as well just be right all the time, and who would ever know the difference, because nobody's going to space, right? I mean, what a cushy gig they got going on, don't they, those theoretical physicists? Magnetic field mystery. It says, an observation by Voyager 2's magnetic field instrument, which works for decades with no maintenance on 70s technology, confirms a surprising result from Voyager 1. The magnetic field in the region just beyond the heliopause is parallel to the magnetic field inside the heliosphere. An alignment of these magnetic fields in the random, infinite reaches of space. Isn't that a bit of a lucky coincidence? With Voyager 1, scientists had only one sample of these magnetic fields and couldn't say for sure whether the apparent alignment was a characteristic of the entire exterior region or just a coincidence. Voyager 2's magnetometer observations confirm the Voyager 1 finding and indicate that the two fields align according to Stone. So I guess that means it did confirm that it was just a big coincidence. They failed to mention that. Like they said, that I love how they couch these sorts of statements, but they say scientists had only one sample of this magnetic field and couldn't say for sure whether the apparent alignment was characteristic of the entire exterior region or just a coincidence. And then they go on to say, Voyager 2's magnetometer observations confirm the Voyager 1 finding and indicate that the two fields align according to Stone. And of course they fail to add, meaning it is one big, giant coincidence. I mean, but the way that they couch it, it makes it seem as if it was not a coincidence, but indeed it is, right? I mean, what are the odds of that? I don't know. So the Voyager probes launched in 1977. God Almighty, and both flew by Jupiter and Saturn, they claim. And yeah, the video that I did a while back on, and I sort of covered Voyager 1 in there. If you look at the pictures that it sent back of Jupiter, it's just ridiculous. It really is. Like, you can totally tell that it's something that they faked in the 70s, right? Because cinematography has advanced so much now. If you have a critical eye for that sort of thing, you can clearly tell, well, yeah, that does look like they faked it in the 70s, and that's, it fits, right? So yeah, they're claiming it flew by Uranus and Neptune. And now one thing that was interesting, and I did kind of want to look into this, and I haven't pulled it up yet, but I know that Voyager 1 was constructed by a company called TRW Inc. And if I'm not mistaken, TRW Inc. went out of business. It went bankrupt right in the year 2000 or something. So I'll just search. I wonder if Voyager 2 was manufactured by TRW Inc. as well. And there was some peripheral, pretty. If I can't remember exactly what it was. Maybe I'll bump into it. But there was some nefarious stuff about TRW Inc. as well. I can't remember exactly what it was, but I remember thinking when I stumbled on something kind of unrelated, they had brought up some stuff about TRW Inc. And man, I wish I could remember exactly what it was. But anyway, they were shit. Oh, you know what? I've got it wrong. It was not Voyager 1. It was Pioneer 1. So I guess TRW Inc. did not build um, Pioneer 2. I'm sorry, Voyager 2. God, I'm getting tongue twisted. So let's just see who built. That's what I want to know. Who built Voyager 2? Okay, so JPL built it themselves, they say, that's pretty rare from what I gather. Like usually, NASA would sub out a lot of their construction stuff to third-party contractors. They didn't do it in-house, and I guess JPL sort of falls under that banner. But okay, and of course that's Jack Parsons Laboratory, JPL, the set one and the same. Jack Parsons, of course, was involved with both L. Ron Hubbard, the founder of Scientology, as well as he was a follower of Aleister Crowley. So he was like a witch and a warlock and all that stuff. And he was integral in the foundation of NASA, right along with all the Nazis and everything. Died in suspicious circumstances in his very lab, I believe, in a fiery accident, if I'm not mistaken. So yeah, Voyager 2 was launched by NASA and built by JPL. And what was the cost of Voyager 2? I'm just curious. Cost of let's do 1 and 2, right? 1 and 2. We'll just get the total cost for both of these missions. Wow. $865 million. Dude, I'll tell you what. I'll send something up better than that on 1960s technology tomorrow for half that amount. It'll work better. It'll work for 150 years. Yep, sure will. Oh man, that's just ridiculous. So, oh man, wow, $865 million. That's crazy. Tax dollars at work, and we get yet another CGI rendering of the hypothetical satellite or space probe with basically less than a toaster oven's power, if I've got that right. Maybe I'm way off on that, but yeah, sounds very believable to me. Right. So I read that. Let's see what else we got here. Oh, the power. I did the power and communications. Did I read through this communications? Yeah, I did. The high gain antenna. I sure did. So I covered that as well. We did the video. Let's see. Let's hear what he has to say about this heliopause.
Here came
I can't hear
from
it
the
though.
detection of
Shit.
the cosmic rays. It seems that as soon as the probes crossed the boundary that was created by our sun, the amount of cosmic radiation increased quite a lot. In other words, it seems that the actual heliosphere protects our solar system from about 70% or so of all of the galactic cosmic rays that would otherwise strike our planet and our solar system. You can see in this graph how as soon as they crossed the boundary, the galactic cosmic rays increased in numbers, but the other heliospheric particles decreased dramatically. And all of this was detected about a year ago on November 5th of 2018. Now this is something that we definitely were quite surprised to find out, and is a really important discovery if we ever want to become an interstellar species. It simply means that there's a lot more galactic cosmic.
It's gonna play an ad. Whatever, and I kind of wanted to respond to the things that he was saying on there, and I still can't hear a word he's saying. It's very jarbled. I can only sort of hear every other word, so I'm not gonna keep playing it, but I will put a link to that in the description. let me check back into the chat here and just see. Wow, okay, still 92 watching, 28 thumbs up. Well, I appreciate that, guys. Um, so basically, you guys know FE 2019 is going on in Dallas. So I wish I could have been there. I've got a lot of friends that are there, and seems like it's a blast. And I'm there in spirit, but not in body, and I wish I could be. So maybe next year. But yeah, so hopefully you guys enjoyed this one. Just more NASA lies, more fake space nonsense, and clearly, like every little bit of the claims that they make, that if you just look into it a little bit, it just doesn't make any sense at all. From the communications strength to the distance that they say that they're sending signals, to the technologies that they have on board, to the power. What was it, 450 watts at launch, and that's supposed to be decreasing by half every 90 years, and somehow they know that. And by the way, the generator system that they're using is really only used by NASA. There's no sort of other practical applications here in reality that you can use this sort of thing for. So we'll just, it's exclusive pretty much technology for NASA, and of course that raises some pretty red flags. So anyway, this has been going on about an hour, so that's about what I wanted to do. I am planning on popping back on a little bit later today and doing another chapter of the Creature from Jekyll Island audiobook, so feel free to tune in for the live stream for that, and maybe about an hour or two at the longest. And thanks so much for watching. It's been a pleasure hanging with you guys. Again, I hope you enjoyed it. Love y'all. And if you'd like to support this channel, you can do so on PayPal or Patreon. I'll put links in the description. So spread the word, spread the world. Oh, and Chow Yun Cat says sent 777 super chat. Appreciate that. Good info. Thank you, Mr. Morgile. You're welcome, sir. I appreciate that super chat. God bless you, man. And God bless y'all. And we'll see you in the next stream. Peace out, everybody. Take it easy.